Hello guys, and welcome back to the third episode of me building this fun virtual camera project. Today is like a homework day, and I'm going to call it UNCUT episode. So I will just do some live coding, record, and don't try to edit it. So it will be complete disaster and full embarrassment. Thus going to be really fun. Let's try. First, I need to switch to my screen sharing stuff. This is how I do it. Okay, so today I want to test a hypothesis about how I called it the driver for the virtual web camera. This is a Linux machine. I want to make sure by the end of this video of the session I want to see a virtual web camera in Google Chrome and Google Meet, like select it and I don't know, black box or some random video, just to test the hypothesis that I can do that, figure out the technology, and overall just see how it works. This is an absolute POC, just me figuring out the technical risks and try before I switch to building the big and huge final application. I tend to test out small components in isolation, like to learn more, to understand the contracts, how they would look like, their shape, gain some experience and knowledge, and then based on that, I just assemble the final application. So the web camera driver, it likely will be some C, C++, and to test it properly, I need a playground. I need a playground, so for playground, I will build a tiny, simple Electron application just to load the driver to generate maybe some video. I really have no idea. But Electron. Also, my first ever time building anything Electron. This really is going to be fun. So my two tools that I will be using throughout this is Cloud Code, probably Opus, and the Visual Studio Code. Nothing fancy and nothing fancy. So let's give it a try. Oh, this is like this. This is complete embarrassment. Yeah. Okay. Okay. I already learned I need to do some npm install. I will do it myself. You don't want to use AI to scaffold to generate the skeleton of your application. My experience says that no, don't do that. Do it by hand like a savage. You need a solid foundation. You need to understand what's going on. Otherwise, you will not end up well. Okay. Because it's a POC, it will be throwaway code. I will create a temporary folder. I don't know how to call it. Cam driver Linux npm init sh Linux version set command repository keywords. Oh yes, it's okay. And we install this command. Electron, nice. No idea what to do next. How do I run it? Can I already run it? Oh no, highly unlikely. I will not be reading the documentation. Let's Cloud Code this thing. Enable thinking, accept edits, play mode. I will not going to be playing anything. Is this thinking mode? Oh, I don't know. thinking that's weird. Okay, nonetheless, we will be working in, how do I call it? This is skeleton for Electron application. When get run. Is it thinking? Yeah, it is thinking. Okay, cool. So really starting small, just make it run. Just see how it works. Just figure out the foundations. Yes, all edits. Just electron dot. Okay. All right, it's HTML. It's HTML. Woohoo! Whoa, from console. Okay, okay. Okay, it works. Thank you. What did it do? Oh, simply HTML, nothing else. Okay, sure. Uh, that was easy. That was very fast. Next thing, the camera driver itself. I have a slight idea, like I'm recording this through OBS Studio. First of all, I noticed that OBS has a similar thing, a plugin, DroidCam or something. And it's open source, so when I eventually, very, very soon get stuck, I will just look up the source code and see how they approached it. This is very cool. This is of a lot of help. Thank you, OBS. Also, having some Linux experience and seeing how this is set up in OBS, I figured out that the technology here to do the driver looks like it has something to do with video for Linux. That's the keyword that will save me. Let's see. Tell me. Let's ask Claude to help me learn, because that's 2025. This is how we learn these times. We don't do Stack Overflow anymore. I never did, actually. I was just going through books, through tutorials and etc. It is very tedious, very boring. It takes a lot of time. With Claude, we can do it much, much faster. But super important, we are doing a POC. This is a new territory for me, so I will not be jumping ahead. I will be maybe asking AI to move me forward and then trying to understand what did I do, how it works, because I'm learning. Not only I'm having fun, not only I'm achieving my goal of building an application to stream from my phone to video calls, but I want to learn. This is what it's all about. So I want to expose virtual webcam on this machine. It is a Linux machine. Tell me more about video for Linux. Yeah, I'm not a native speaker, obviously, so my prompts sometimes are pretty cryptic. So let's see what it says. Virtual and output devices. That's what we need. Here, now for create virtual webcam. is a framework that handles audio devices. Okay. For creating virtual webcam, we'll use to, if I look back, okay, kernel module that creates virtual video devices. Cool. So there is a kernel module. It will create a device for me. And then this device will become visible everywhere. Oh, and it figured out that I'm building an Electron application. Nice. Ah, because I asked it to do. Sure. I wonder, so just writing to a device like to a file, that does not make sense. Directly write, unpack, sure, thank you, unpack is the best. Is writing to the device directly via file is the only option, or there is a platform native interface API to do that? So yeah, like super cool. I load the module. It will create a virtual device, but writing to it like a caveman, that just doesn't seem right. So, well, yeah, this is the one. This is what I think shouldn't be I shouldn't be doing. But I get a file descriptor. Okay. Direction layers. Is it the option? So it's the flow. No, it's still like there won't be a function open v4 L device blah blah blah. You still it's Unix Linux. You open it as a file, get a descriptor, then you set some parameters. Okay, okay. Tell me more about. By the way, I forgot the thing that this is a clean project, that's why Claude is not set up at all. I don't have any files, like the folder is really clean and empty. What I usually do is be extremely concise and sacrifice grammar for the sake of concision. At the end of each plan, give me a list of unresolved questions, if any, and keep them concise. This is extremely cool because we don't want all this theater with M dashes and etc. And sometimes AI starts to speak to me as if I'm like a 5-year-old. This is super creepy. I just want it on point. I'm learning. I'm very focused. I don't need this thing. So it is for the second time. It is mentioning the Node V-File camera. Tell me more about Node V-File camera. It is super convenient that it already exists. It's already called camera, like V4L. Node V4L camera. Is it hallucinating it? No, it does exist. 10 years ago. 10 years ago. Start capture. So it's actually not for exposing a camera. Capture is for capturing. So that the opposite. That's not what I need. Wrapping primary for capture. Yeah, this is what it's saying. Output. Yeah. Think it won't work for me. I need output. Versus uses FFmpeg. Like I think invoking FFmpeg for every frame will be pretty weird. Yeah, we really need a native add-on. Let's go with a native add-on. Okay, what will it do? Grab binding GIP. SOC. Woohoo. JS interface. Okay. Wow, it removed start script. Ah, it moved it here. Okay, sure. GIP. What's GIP? GIP. Native add-on build tool. So Node.js has an ecosystem of native add-ons. Cool. What I do enough comparing examples module for Node.js. It contains standard copy of the project. Blah blah blah. Of course. Ah, okay, it's the opposite. It doesn't require Python, but if you're using Python, then you need the latest or whatever version of Git. Oh, I was worried that you will need to install supported version of Python. So in order to write some JavaScript, no, in order to write some native add-on in, let's say, C, that I will run through JavaScript in a Chromium, running pretending to be a native desktop application on Node.js, I need Python. Python is everywhere. This is unhealthy. Mod.info, yeah, module, so it will ask for sudo. It won't be able to do it. That's why I opened the second terminal, just in case I need to do that. Yeah, sure, let's try. Okay, it loaded something. Video 10. It created this video 10. Nice, that's cool. Let's actually try. Boom. Unavailable. Okay, not yet working. It's harder than I thought. I ran the command. Video 10 is here. What's next? Okay. I wonder if, yeah, like after I create the device, I need to initialize it a bit, and only then Chrome will recognize it as a camera. See, still nothing. Yeah, doesn't show anything yet. Yes, let's integrate it. No, that's not what I want to do. Okay, it is telling me video for Linux. This is the way to go. The way how it works is that I load the kernel module, provide some parameters telling the device name, telling the something else, and it will register a new device as a file under /dev. if I do something extra, I believe then Chrome will pick it up, and from my Electron application via some low-level module, I need to configure it, set up its frame size, width, height, maybe quality or something. Then I will be able to just send frames to it, and hopefully that's how it works. So to test this hypothesis, I have these, let's say, two initial steps. Step one, no, three, okay, two steps. Step zero, understand what the hell I'm doing. Step one, see this virtual camera in Google Chrome. Even if it's a black box, even if it doesn't work, doesn't matter. Step one, I need Chrome to recognize that there is a new device on my machine. And then step two, this is a playground, this is POC. I really don't care about like the final solution yet. So I will use Electron, I will use Claude to generate some video stream, like some, I don't know, circles and etc. that I will send to this device, and on a video call I will see the fake video stream coming from this device, coming from this custom software. Let's first solve thing number one. See it in Chrome. I open. So the module is here, the device is here, but when I start a new Google Meet session, Chrome does not show the new virtual camera in the camera list. Then loading it again. What is it doing? It told me device show the module. Then restart Chrome completely. Devices one, video, I don't know yet what it means. And we file to CTL. Whoa. Video capture, video output, read write, maybe. It says I need to restart Chrome completely. I don't trust AI. Sometimes it's right, but let's think that we are smarter. Okay. Still unavailable. Do I have MPV? Hello, did it hang? Oh, that's sad. Yes, please. Let's continue by creating scripts. No, after I restarted Chrome, the camera still didn't show up. Okay, it hallucinates that it needs a signal. Okay, creates me scripts. Where did it create me? Where is it? Here, scripts. Download module. Okay, let's save. Start camera. Oh, test.js. Okay, we'll see what's that. It loads. Device. Video 10. And this test.js is It opens. Create cover frame. I have no idea what's that. Yes, integrate into Electron. Yeah, shows wasted from should be able. Test.js is running. Yeah, while it's doing its magic, let's test again. Still nothing. It probably stopped test.js while I was testing. UI controls. Oh, renderer. Oh, what's going on? Probably it did read my mind. So Electron and the dot. Starts running. Oh, it is sending frames. Woohoo! Okay, okay. Ready. That's so exciting. Camera unavailable. That's what we are looking for. Still not available. Show more info. Try again. Something is off. Not showing up in Chrome. Check user in video group. I'm not in video group. User mode. So it recommends me. No, I'm not changing my user's permissions to access video device. That's just nuts. Where other? The actual camera is probably video 0, video 1. It's still like this, absolutely the same permissions. No, something is off. Let's try. Chrome, Crashpad, Handler, Slack, Discord, Steam. That is a lot of Chrome running on my machine. I tried, but didn't work. Does Firefox different browser? Okay, it's always. Do I have Firefox? No, I don't. What's this? Edge. Do I have Edge? No, I don't. App MPV. Whoa. Oh yeah, 10. Yeah, I think MPV is not an answer. Probe. Oh, it's raw video. MPV doesn't show anything. I mean, literally nothing. Even not showing any windows. Device broken. Okay, of course. Device broken. Oh, We want to proceed. Like it just killed the app, so the device has nothing. Well, the device open, sure. Using simple write needs proper streaming API. Ah, it is probably writing to the device for me so that I can try Chrome. No, that's not how it works. Okay, heavy artillery. I already cloned the OBS Studio source code to this machine. The folder, no video. In the studio, there is source code of OBS, and OBS has a virtual webcam driver. Check there what we are missing. Maybe wrong kernel module params. I think this guy needs to be killed. How do I kill it? Bye bye. Did I kill it? Yeah, killed. Oh. Missing stream on. Of course, stream on. We forgot stream on. What's stream on? Open code. Let's talk to you for a while, for a change. What else? Because we are poor, we will be using free stuff. Speaking of media for Linux, what did it say? What's stream on? Whoa. It said that we need stream on, and now it's doing stream off. That is weird. That is weird. So edit stream on was RAM. This guy is thanks Big Pickle that you're free. Otherwise I think I wouldn't be able to afford what's going on here. Okay. Ready to test. Ready to test. Crack on. Cut. think it's toast. Okay, waiting for task. Status stopped. First of all, just out of curiosity, I will not hit start camera. Now we changed the parameters for the kernel module. I wonder if that was the culprit. No, it wasn't that. Okay, let's start the device or resource busy. When I hit start camera, it says device or resource busy. Ha! Module needs reload. Module needs reload. Okay, hold on. I think let's start owning this. This said I need load module. Load module. I don't trust it. Let's unload first, and then load again. Then we will Chromium. Okay, now we really have the module loaded with a bit different parameters. Still nothing. Doesn't matter. This guy is toast. Kill. Who? Wow. I thought I killed it. Works now. Try start camera, but I killed it. So run start. Before I started. This. Okay, let's try again and look more carefully at the error. So I start camera, failed invalid argument. Start camera fails invalid argument. Wonder other any build scripts already? JSON build install. They do the same, so npm build, npm start. I wonder, hold on. Mine is already running, so I don't need that. Okay. npm. After reload, restart Electron. So devices 1, video NR10, exclusive caps 1. Let's take a look at the load module in exclusive caps. Let's try. Linux. Let's click. npm and start. Just in case. What if I do it like this? Still invalid argument. Nothing works. We are doomed. AGI is not here. Some more random code. Of course, that's what we need. More random code that we don't understand. So we decided that we need stream on. Now we decided that we don't, but for sure, of course, after we revert it, it will start working. No doubt. Oh, at least it didn't crash. Woohoo! MPV, start camera worked, but MPV still doesn't show literally anything. Please might need specific file, but device proven working. Try Chrome. No, it does not show up in Chrome. Actually, let's do this. No, it does not show up in Chrome. Opus, please save me. You're 3 times more expensive. Sure, of course. Half an hour ago, Chrome was ignoring the video capture only once. And so we made it video output, but now it ignores the video output. Did you take so exclusive caps 1? This is the problem. Filters out showing output caps. You must run. Are you sure the command line changed? I think it was like this before. Your script might not be the smartest one, dude. For 0 output capture capabilities. It's an array. It's an array. Run again. Okay, of course I will run it again. Let's kill it. Oh, it's different now. It's different. Yes, I saw some wires. npm run start. Oh, whoa. Who does that? I will run it. Okay. Guided, right. Running. Okay, still fails. What will Google tell me? Camera is started. Oh, that's not this. Okay. Virtual camera. Virtual camera. Virtual camera. Here it is. Whoa. Hello. Hello. We are seeing something that we cannot control we don't understand it, but we are seeing it. It's the first step to victory. It worked. Opus. That was Opus, guys. It just suddenly decided to figure it out. Okay, summary of what's working. Native if writing UUD frames with exclusive caps Y, ROM sets. Next step, we see frames from network, different resolution format. First of all, okay, I will not make a note, but I think eventually I will need to learn more about the frame formats. These cryptic letters are very concerning. That might become a struggle. Let's improve. No. What do we do next? So, we are like in the middle of, we achieved the goal number 1. Chrome now shows the camera. The goal number 2 was to stream some fake video through that camera. We are kind of technically, here we are, but it is, I'm not even sure who is doing that. I'm not really sure. Who is generating those frames? Is it index.js? Oh, it is index.js. Okay. So Node.js, Electron, most likely highly inefficiently sending video frames. Okay. Okay. Then looks like we achieved the goal number 2. So we are doing it from our code, from the code that we can control. It's JavaScript. We all know JavaScript these days. It's super easy, much better than Python, much easier to comprehend. I think it's terribly slow because we are highly likely crossing memory boundaries here. So inside the JavaScript VM, we are generating a frame, and then we're like copying this memory snapshot, memory buffer through the boundary to, how did we even call it, to the native add-on. And we are doing it 30 times per second, so doesn't seem right. For a starter, that's good. Real video source apps closed. Okay, network streaming. That will be our next step. Let's do some screen capture. So I believe what Opus will do for us is that it will update the index.html and give us a button to start screen sharing using the Electron quote-unquote functionality. This is still very similar to index.js, but it's just another test to confirm that various ways of generating video really work. Oh, look, I was right. The frame format seems to be very important because the guy is generating some conversion already. Desktop captures. What's CPC main? Handle camera get sources. What's that? Handle. So JavaScript code responds to something. So I wonder who is calling it. Whoa. Okay, repeat the source. Okay. All right. We succeeded. Only 20% CPU. Only 20% CPU out of how many? 16. Okay, it's 8 real cores. Two 20% CPU, so 2 cores are writing frames through JavaScript to this virtual web camera. I wonder if that's true. Okay, stopped. Will it go down? Okay, we are at 13, 15. If we stop this guy, you know what? Maybe it's just 10%. No, we are at 1.5 gigahertz. Let's try again. Whoa. Okie dokie. The performance is not great, but I think the POC is somewhat successful. So what we achieved is that we now know how to expose on a Linux machine, how to expose the virtual camera. So to do that, you use Video for Linux. You use like a kernel driver, you tell it to register a device. Then in Node, in Electron, we open this device and just start writing frames to it. It's again highly inefficient. I will need to think a bit how to make it more performant. Essentially, I need to learn more how to avoid this crossing the memory boundary. If this is even an option, I don't know, but bringing down the CPU usage, that's probably important. Like 17%, 16, yeah, actually it's not terrible. It's not that bad, but the gigahertz, the frequency of the CPU cores went up. It really is doing something. That's not great. We want to save battery. But it's a pretty old machine. It's Intel, and ninth generation, like from 5 years ago. So maybe not a problem at all. Okay, so we can do that. And not only we can write, Opus figured out for us how to write individual frames, but it actually figured out how can we generate media stream on the JavaScript side using the JavaScript browser APIs and send this media stream to the device. So we are kind of getting flexibility here. We will be able to do some post-processing, background removal, coloring, filters, etc. if we want to. Not sure that we will, but that's an option. Let's increase final test. It is actually using a very low-level resolution, but it's a video call, so we want not 4K, obviously, but full HD. This is what we want. I wonder if it will blow up if we try to do that. Resolution to full HD. Also, because it is a kernel module, we will need to figure out some scripts that start the video camera, stop the video camera, and don't ask a user any questions. So it needs to somehow go seamlessly without asking for a password, without all that kind of stuff, because that will be a really terrible UX. Let's see how it is doing with the high resolution. Whoa! What the hell? There is a terrible lag, no? Yeah! Now we are at almost 30% of CPU usage. Okay, the bottleneck is definitely here. The bottleneck is absolutely here, and to be honest, this is a bit concerning. It feels like there is a very terrible lag. Frames 120. Let's stop Chrome. Yeah, my machine is becoming unresponsive. On this resolution, it's just not working out. It's slow. I wonder if the video, the one that I'm recording right now, what if, like, for the last few minutes, I'm already a robot and breaking up. Okay, nevertheless, let me go back here. It is an uncut video. It was me experimenting. Claude helped. We filled in some knowledge gaps. I still need to digest what happened here and learn a bit more about the performance issue. I won't be able to do it live on this video because it really needs some thinking time, but I will get back to it. I think that's it. Thank you very much. Hopefully, not only me and my wife will rewatch this video, and see you next time. Few minutes passed and I am back because I was not fully honest with myself. So in the beginning of the call, in the beginning of the video, I said that we will be using AI, we will be using AI to learn and not to just solve for us and move on. But I tried to finish the session, the video, saying that, okay, I will digest this, something works, and I will figure it out later. But no. So actually, after I stopped the video, the recording, I told Claude that, hey, it is slow. And what happened next? Next is that the guy said, yeah, it is. And remember, I shared that this frame format, all these conversions, might be a friction point. And Claude confirmed that, yeah, at this resolution, there was this function that I noticed initially that converts from RGB to this cryptic format, and it was doing it on the JavaScript side. So it was taking 2 million pixels 30 times a second and doing number crunching and converting them to a different format, like a lot of math and etc. So Claude rewrote it and re-implemented it and moved the conversion to the native add-on. So, and I figured out that, is it C++? It looks like C++. So it moved, what's the RGB, right, RGB frame. So it moved this terrible math to C++, to native add-on, recompiled everything, and look. Let's do this. It is now kind of not lagging. All good. If we do Google Meet, it is much faster. It's probably real time. Bitop. Bitop is still showing numbers that are concerning, but like no more. Last time it was 30, 35, 25, but it was peaking to 30%, I think. Right now it is still, I would say, no more than, let's ignore that it now shows 22, 23%. Let's say it's around 20% of CPU usage, which was actually similar to the very small window pure JavaScript. Now it's full HD with a lot of manipulation happening in the native add-on. So the problem is not that urgent, right? It was a problem. There was a terrible performance problem. Now there is none. I mean, the terrible problem is gone. Probably there is still a bottleneck, but I think, yeah, I will ignore it for now because the goal was to build a POC to understand how do we do this on a Linux machine, how do we expose a virtual webcam driver, how do we send a video stream to this webcam driver. We learned a bit that we need to do some frame conversion. We optimized performance a bit. So we learned the foundations. We know the building blocks, and we shouldn't be optimizing and making it production grade at the moment because we still need to figure out networking and the way how we will be sending video frames from the phone to the desktop to the laptop. The reason why it is important, I mean, obviously it is important because it's part of the final application, but it will be networking. We will be using a WebRTC library that is backed into Chrome and Electron, so there will be native part involved. We will have access to the video frames. I have no idea what format WebRTC, what format of the video frames it is using. Will we need to do any conversion to send it to the native add-on or not? And like memory boundaries, all that kind of stuff, it's really unknown. But we know for sure that on the network side, there will be some memory and frame conversion involved. We need to learn more there. And only then we will have the complete picture about do we need or do we not do any performance optimizations. Right now, the picture is unclear, and if we make it, optimize it to a state that it is consuming only 1% of the CPU, chances are that when we integrate the networking here, we will have to revert all that, and it will be a wasted effort. So that's why in the beginning of the session, I called it a POC. We're just learning. We're building a small playground to understand a small piece, a foundational piece of the final application. Once we understand all the pieces, only then we will have enough knowledge to move forward and to start building. This is the exploration phase for now, and that's absolutely fine to generate sheet code, to do a lot of AI, and etc. But we need to learn. We are learning. And that's why let's spend a few more minutes here and ask Claude a bit of clarifying questions. First of all, what's renderer.js? First of all, I would like to understand what's this IPC main handle. So I will ask Claude to explain index.js to me. Now please explain index.js to me. I am new to Electron and I never built JavaScript native add-ons. Okay, let's see. Introduction, main process. There is Node.js, sure, can use native add-ons, nice. So remember, JavaScript and TypeScript might be the only languages that we need in the near future. This Windows runs in the background. Inter-process communication, there is main process, renderer process. Oh, interesting. So Electron is already two processes. It's like classic three-tier architecture, MVC, model view, controller. So there is the controller, whatever, and then there is a view. And actually, Node and Chromium are kind of separate from each other. Okay, EPC main received messages from renderer. Where is the native add-on? EPC main handle. So I wonder, index.js is the main process where we can interact with native, but we cannot render. And so then there is the HTML, and it communicates to the index.js via IPC, sends messages, sends data, and does HTML, which actually means, like, I wonder, can I use any web framework here? Probably yes. Like, why not? I can build an Angular application and just run it as a desktop one. Why not? So IPC handle desktop capturer. Start camera. It's still and it writes. Array buffer. Here is the probably memory boundary thing, array buffer and node buffer. I will need to learn more. Camera writer GB. Oh, interesting. Look. So this camera thing, new virtual camera. Was file output. Zero syntax here, target name. Virtual camera, leap camera. Leap, oh, virtual camera. Output, who is out? Oh, nice. So those native add-ons, it looks like we implement a class using C++, and then after some magic happens, this class is actually exposed to us to JavaScript with all the methods, and we just can call them. That is nice. Let's double check this. Is there right frame method? Oh, I think we need to install VS Code plugin for C++. Right frame. Oh, okay, sure. So it defines how to expose methods. Okay, cool, cool, cool. I was worried that there will be a lot of like low-level mumbo jumbo with headers, linking, etc. But this is pretty straightforward and not scary at all. So we write some C++, then using Node.js APIs, we export those classes to JavaScript, telling that, hey, this will be the class name, this will be the instance methods, and when JavaScript calls the instance method, this is the C++ equivalent that needs to be called. That's cool. That's interesting. And I think this class doesn't need to be in the lib folder. It's probably the best practice just to separate, do some solid and separate concerns. Okay. And so this index.js instantiates this class from our wrapper, sends stuff, and it does this camera start. Start camera. Whoa. Okay. Optimization found. Start capture. Function. Start capture. PC. Invoke camera stop. Renderer. Invoke. So camera gets sources. Camera start. Oh, interesting. And this IPC thing, probably it can do everything for us, but at least the way how it is used into generated code is that we always have an access to an object called IPC renderer, and it's really it's not doing message like sending messages so that it's fire and forget, and we need to send a message and then sit and wait for the response message, match them, do some timeouts, and etc. But it is already RPC for us, so we invoke a thing, provide a name. I suppose, yeah, we can pass arguments, camera right frame, and here camera right frame, and here IPC main object just says, okay, when someone invokes right frame and passes these arguments, we do stuff and return a thing. And for the calling code, okay, here we actually ignore the response, but for the camera start, we don't. And it's a JavaScript promise. It's a synchronous JavaScript promise. That is starting to make sense. Right frame, browser window, that's boring. So the index.js, the primary method, primary process, starts the thing, starts the add-on, and then the renderer, when a user clicks buttons, interacts with the application, it, through IPC, invokes some handlers on the index.js side. And the good thing here is that because of this separation, index.js is running in Node, so it has access to all the stuff in the world, to the file system, to the network, to the operation system, etc. So initially, and as I said, it's my very first Electron application, so I didn't know how it worked, but I was under impression that Electron is a simple wrapper around Chromium, and it starts Chromium and runs your JavaScript inside Chromium as if it's just a simple web application. But looks like not. Looks like Chromium is a separate process, but then there is a main Node.js process, and they are able to talk to each other. That really gives us a lot of flexibility in terms of what we can or can't do. That looks really promising. That looks really promising. And by the way, I wonder, what about context? How much did we use for this session? Wow, look, we actually managed to still have some free space and didn't achieve any compaction. Didn't require any compaction. That's cool. We were pretty efficient. Remember, in the beginning of the session, I said that I really love to tell AI to be extremely concise and be on point and etc. So this is the result. It was pretty concise, and we managed to save a lot of tokens, and we did not experience the context compaction, so AI did not turn dumb in the middle of the process. That's cool. Because final thing, because we are learning, we don't want to lose this knowledge. So I will ask Claude to write down the summary of the session in an MD file, so that later on I can reread it and use it for the next session, etc. Maybe I will just eventually delete it, never read, but who knows. So capturing knowledge is very important, and you absolutely should do that at the end of your session, or in the middle if you discover some new concept or gotcha. So let's do it. Let me figure out. So docs, write down summary of the session in our language. It docs file empty Electron empty. Hello. Yep. No knowledge, no learnings. We saved some tokens, but still we reached our limit. Okay then. It's a sign. See you next time. Bye bye.